So welcome to this B attributes course. This is a B attributes course on occlusion. So the occlusion attribute asks what percent of this object is occluded, and the choices that can be selected are 0 to 20%, 20 to 40%, 40 to 60%, 60 to 80%, 80 to 100%, and can't tell. So before we go into how to make all these selections on occlusion, first we're going to go into what occlusion is. So what is occlusion? So occlusion measures how blocked an object is by other objects in camera view. So if you look over here on the little diagrams, number one, that is a car that is reflective of being occluded by 0 to 20% occlusion on that car. So like that means it's blocked off at 0 to 20%. So that we can see most of that car in that image, and that means that it is not very occluded. In the next example, number 2, we see that for 20 to 40%, more of the car is blocked off than the first example. So that shows that as occlusion increases, the more it is blocked off from our view in camera view. So as we're looking at the cars and as we're seeing the occlusion increase, it becomes harder to see because the more it gets covered up by a different object. And here we have a car that is 0 to 20% occluded. And at 0 to 20%, and we're asking how blocked off is this car, we see that from our camera view, it's not being blocked off by anything. There's nothing blocking it off in this example. So 0 to 20% is reflective of occlusion, of the lowest occlusion level, where it's not even occluded at all. So this is the choice in that case. And here we have another example. So if you look back, this is the car that we're looking for. And in this frame, we don't even see the car there. So here, this is a car. It's like, it looks like a sedan. And then we look at this car. It looks like a hatchback now. But that's not because it's turned into a hatchback. It's because there's a hatchback that's blocking our view of this car in the camera. And so we don't see the car anymore. The car is actually in front of the car that we're looking at, and that car behind it is blocking off our view of it. So since we can't see it at all, there's no view of that car at all. We're putting the max occlusion level here, and so the max occlusion level is 80 to 100%, and that's because, and so that means that it is we've found out that it's 100% occluded. It's 100% blocked off by that car behind it that's in front of us, and so that is 100%. We've determined that it's 100% occluded. Let me say that again. So here we see the car. Here we don't see the car because it's 100% occluded by the object behind it. Right. So the less blocked off an object is by other objects in camera view, the less occluded it is. So the smaller choice is the less occluded choice, and the higher value choice is the higher occlusion choice. And occlusion is a attribute that is not global, and it has to be adjusted per frame. So if we looked at that other example right here, uh, this may have been one frame where it's the occlusion level was 0 to 20%, but in this frame, it's 80 to 100%. So that's something to keep in mind, that we need to adjust the occlusion based off of each view, based off of each frame. So here are some more examples of 0 to 20 occlusion at 0 to 20%. On all these examples, we have an occluded vehicle, but well, actually, the only occlusion that we see on a vehicle here is the white car that is behind a couple of poles, or some poles that are in front of it. Otherwise, there's slight occlusion on the car that's this car right here. The freeway dividers very minimally blocking our view of the car, but in the other frames, it's not, they're not being blocked off at all, or the other examples. Even though in that bottom example right here, this one, let's get a bigger view of it. Even though it's hard to see that car, that's not reflective of how occluded it is. So there's nothing blocking off our view of that car. The only thing that's making it less visible is how far away it is. Like maybe we can't clearly see its lights, but that still doesn't make, doesn't make it more occluded just because it's more invisible. It's not blocked off in our camera view, and so that is a fine example of 0 to 20% occlusion on a car. And now onto the next level of occlusion, which is 20 to 40%. So with 20 to 40%, that means the object is slightly to moderately occluded. We could see most of the vehicle, but it is being covered up slightly. And then 40 to 60% means that the car is more occluded, is moderately occluded, to more than half occluded. So if we look at these examples here, we can see less of the vehicle than we were able to see in these examples, but we can still see a decent amount of the vehicle. It's not completely covered up by other objects. Now, and then 60 to 80% occlusion, that means we're seeing a lot less of the car than we were before on the lower levels of occlusion. So it's getting harder and harder to see. So in these examples, the left example looks like the car is almost completely covered up. We can only see the tip of its front end. And then on the right, it's probably on the lower end of the spectrum, but it's still heavily occluded where we don't see very much of the car. So 60 to 80% is good on both of those. And then we have our max level of occlusion, which is 80 to 100%. This is where we can't even see, or we can barely see the cars due to a heavy occlusion. And in all these examples, so on the left, we can make out a bit of the vehicle's like back end, but it's through glass. So glass is actually not, it's considered just like it's considered as a other object that's covering up the vehicle. And even in this case, the glass does not, reveal very much of the car, so it's actually being very covered up. And the max occlusion level is definitely appropriate for that choice. And the next image right here, the vehicle, the vehicle in front is completely blocking the vehicle that we're looking at. We can see its side view camera a little bit, but that's all we're able to really make out. That we might be able to see some of the roof, but we really can't see very much. It's very difficult. Same thing on the right image. Uh, we can barely see a car that the red car is blocking off because the red car is turning in the intersection. Um, so that is another great example of a 80 to 100%. So when do we choose can't tell? So we choose can't tell for no label zones, or if the camera quality is making the car look so blurry that we can't tell how occluded a car is. Um, that's not to be confused with the max level of occlusion. If we can't tell where a vehicle is because it's being blocked, that's different than we don't know how occluded it is. So be careful with can't tell. Don't get it confused with 80 to 100%. All right, and so here we have an example where we have two camera angles of an object on a frame. This car right here. So on the left, we can see a very little amount of the car. Um, and on the right, we can see a little bit more of the car. So uh, how do we handle occlusion in this case? We might have two levels of occlusion here. So just to give like a comparison, that that occlusion really matches like what 60 to 80% is on occlusion. So I'm choosing 60 to 80% for that camera angle, and then for this camera angle, I'm choosing 40 to 60%. Okay, and so what do we do in this case? Now we have two occlusion levels. So what we do is we use the least occluded camera angle to base our selection on the frame. So in this frame, we would choose 40 to 60% on occlusion because we're choosing the least occluded camera angle as a basis for our attribute selection. So here are some critical errors to watch out for. Critical errors are mistakes that are obviously and severely incorrect. Here's one example of a severely and obviously incorrect example is occlusion is set to 0 to 20% for all frames when it shouldn't be. Like this is like if a car is maybe visible in one frame and not obstructed by another vehicle or occluded by another vehicle from our camera view. But then in later frames, we see that other cars start blocking our view of the car in the camera view. And then we see that the frames don't reflect that. They're all set to orange, which is 0 to 20% for all the frames. That's a very obvious error that is considered a critical error. Another critical error is one that's typically very easy to spot out. So if occlusion is set to 0 to 20% on an object that is clearly occluded, that is also a critical mistake. So here's an example of a vehicle that we're looking at. We can't even see its front end at all because it's being blocked by a car in front of us, and the occlusion level is set to 0 to 20%. That is also a huge critical mistake because it's obviously occluded. So another critical mistake would be using the max occlusion in a situation that deserves the min occlusion. So in this case, we're looking at the white car with over here with the lights on, and its occlusion level is set to 80 to 100% on this frame. So that's the complete opposite, that we would choose 80 to 100% when a car is completely occluded. So the correct choice would actually be 0 to 20%. That is okay. Uh, Making this kind of choice is a critical mistake. A non-critical error is an error that isn't as obvious and might be even a bit ambiguous. For example, if occlusion is off by one option, like 0 to 20% versus 20 to 40%, that is considered a non-critical error. So that's that same example where it was a critical mistake set to 0 to 20%. That's a critical mistake if it's set to 0 to 20% in this instance. But it's kind of a tough, it's a tough draw between 80 to 100% versus 60 to 80%. Uh, in this case, I would say 60 to 80% is the better option. But if 80 to 100% is chosen, it you know it's a non-critical error, um, and that's something to be considered. We want to prioritize the very, very critical errors. So occlusion is another um, attribute that we can color the cuboid by. So if we color the cuboid by the occlusion attribute, orange is for 0 to 20%, purple is for 20 to 40%, green is 40 to 60%, blue is 60 to 80%, yellow / lime green is 80 to, or sorry, yellow 80 to 100%, and purple is can't tell. You can you can color the cuboids either by cycling through with the clicking the L key, or you can hit the color palette on the attribute, and that will change the cuboid color by the attributes. Okay, so occlusion is non-global and must be adjusted per frame. And here we have the frame selection and the color of each attribute. It reflects on the frame selection, so you can easily tell what attribute is set to which frame. Alright, so in this video I'm going to show how to set the occlusion on a vehicle. First I'm going to color the cuboid by the occlusion attribute. I press the color palette tool. I also collapsed the 2D view so I can get a good view of the camera in the side panel. So far so good. Pretty occluded vehicle in the beginning, and as I'm progressing through the frames, the occlusion level is starting to decrease. I'm just gauging what I'm considering to be the occluded portion of the vehicle and choosing that attribute based off of what I'm seeing. And so far now, for the rest of the frames, 0 to 20%, which I can tell because all the frames are colored orange and the cuboid is orange. Cool. Yep. And that does it for the occlusion on that vehicle.